what we can say, flanged sections. Okay, so we are going to see the analysis of flanged sections. So flanged sections means what? Now this is called as flanged section, a T section. Okay, this is called as flanged section. This L section, this is also called as flanged section. The analysis procedure for both the section is same, but mostly this section is always asked in the examination. Okay, so these are called as flange section. As you know that this is called as top flange, or we can say here only one flange is there, and this is called as bed. So now we will learn that we are going to learn what is T action. Okay, what is exactly T beam? Now when I say T beam, you may imagine that a beam which is having a cross section of T shape. Okay, because what is the thing for rectangular beam? We say that a beam which is having a rectangular section is a rectangular. So likewise, if you say for T beam, a beam which is having a T section, it is T beam. Okay, so but it is actually not a T beam. It is a rectangular beam, but it produces T action. म्हणजे काय होते ते बघा. Now suppose this is the slab. Okay, a slab है. Suppose this is the slab. Okay. Now when you are casting the slab, at the same time if you cast the beam. Okay, so this is the beam below the slab. Okay. At the same time if you cast the beam, so this becomes a monolithic construction, because at the time when you are casting the slab, at the same time you have casted the beam. Okay, and in addition to this, if the main reinforcement in the slab is parallel to the length of the beam, okay, now suppose it is two-way slab, then there is no question, the main reinforcement is always parallel. But if it is one-way slab and the main steel of the one-way slab or main reinforcement of the slab is parallel to the beam, okay, then this slab will act as a flange of this beam, and this slab will help this beam to resist the compressive stresses. Okay, so extra compressive internal stresses will get generated. Okay, so this action is called as T action. This action is called as T action. Okay, and that is why this is known as T beam. So in this T action, this is slab.
Recording in progress.
Okay, so what I was telling you, this is your slab, and below the slab beam is there. This is the cross section of the beam. Okay, if you see length will be like this. Here the length will be there. Okay, behind this अशा length गेलेले असणार पाठीमागे. So this is not a flange, this is actually slab. Will act monolithically with the beam, and this is your beam, rectangular beam, and this slab is act as a flange. This slab will act as a flange, and this beam is act as a beam. So combinedly together, this is called as T beam, and it generates T action. Okay, T action म्हणजे काय की वरचा जो स्लॅब आहे तो आणि बीम जर एकत्र तुम्ही कास्ट केले आणि स्लॅबचं जे मेन स्टील आहे हे जर बीमला जर पॅरलल असेल बीमच्या लेंथला किंवा बीमच्या स्टीलला, तर तिथेही टी ऍक्शन डेव्हलप होते. ओके, so this is basically a T beam. So you write down some theory about this T beam. I am writing here, you just copy it down. So in RCC structure, when slab and beam are casted together, the construction becomes the construction becomes monolithic. The construction becomes monolithic. Okay, monolithic म्हणजे एक साथ एक जीव. Okay, when the RCC slab and beams are casted together, the construction becomes monolithic. Okay, so this is first point. Then second thing is, so what will happen? So some portion of slab, above the beam becomes the part of the beam. Which helps in resisting the compression stresses. Okay, so some portion of the slab above the beam becomes the part of the beam, that I have already told you, this part of the slab which becomes the part of the beam. Okay, it behaves as a single structure. Okay, and which helps in resisting the compression stresses. So compression stresses are get resisted. It will give you an extra edge to resist the compression stresses. Okay, so therefore the effective section of the beam becomes a flanged section, having T or L shape. So the portion of slab section is called as flange. The portion below the flange the portion below the slab. Okay, the portion below the slab is called as web. Okay, so now this is the thing, what is T or L beam. Okay, So now for condition for flanged section. What are the conditions under which this T action is getting developed or L beam is getting generated? Now see, T beam is T action is always getting generated at midpoints, at the centers or intermediate supports for the intermediate beams. But when beam is at the corner, so corner beams are the L beams. ओके, कारण कॉर्नरला एकाच साइडला तुमची फ्लॅंज असणार आहे, दुसऱ्या साइडला फ्लॅंज नसणार आहे, कारण की तिथून पुढे स्लॅब तुमचा कंटिन्यू नसणारच आहे. ओके, so those are L beams. So whatever we are taking, it is same for T and L beam. So now what is the first condition for this T action or L action? The first condition is the slab shall be cast integrally with beam so that it effectively bonded together. If the main reinforcement of the slab is, I already told you, the main reinforcement of the slab is parallel to the beam. Okay, so this is also the condition. So these are the two conditions. Okay, in these two conditions, the flange sections, the T action or L action is developed. Okay, T action or L action is developed. T action or L action. Okay, so these are the two conditions. Remember this condition. The slab is cast integrally with beam. It's effectively bonded together. म्हणजे काय तर स्लॅब आणि बीम हे एकाच वेळेला कास्ट केले असलेले पाहिजेत. फर्स्ट थिंग. सेकंड थिंग इज दॅट द मेन रिइन्फोर्समेंट ऑफ द स्लॅब इट शुड बी parallel to the beam. Okay, it should be parallel to the beam. Then and then only this action will get developed. Okay, so now there are three conditions. Okay, so there are three conditions in this. So we will see one by one each condition. Okay, three cases you can see. So case number one. Case first. What is the case first? When XU is less than DF. This is your case number one. So now what is DF? XU is already known to you. Okay, that is the depth of the neutral axis. What is DF? DF is the depth of the flange. DF means what? Depth of the flange. Now if I draw the T section, now this is the flange. Okay, so this is the width of the flange. Okay, this is the depth of the flange. This is width of the beam. Okay, and you know that overall depth. So this is your BF. BF is width of flange. So I have right here BF. DF. DF is the depth of flange. F stands for flange. Okay. Now this is the width of web, so I will write BW. This is the width of web. Okay. And suppose now the steel is provided here. Okay, so your effective depth will be from top up to the center of this reinforcement. That will be your effective depth D. Okay, effective depth, if you, I will draw it once again. What is the effective depth? This will be your effective depth D. Now see here, XU is less than DF. XU means what? What is the meaning? XU is the depth of neutral axis. So if your XU is less than DF, म्हणजे तुमचा neutral axis कुठे असायला पाहिजे? Flange मध्ये. Your neutral axis lies within the flange. That is the meaning of XU is less than DF. So if I draw the neutral axis, the neutral axis somewhere may be here. This is the neutral axis. Okay. This is neutral axis. N A neutral axis. Okay. So XU is less than DF. ही बघा DF मोठा आहे आणि त्याच्यापेक्षा XU लहान आहे. This is your XU. Depth of neutral axis is XU. XU is less than DF. Means what? याचाच अर्थ काय? In words, if you want to interpret this, it tells you that your neutral axis is lying in the flange. The meaning of this is neutral axis lies in flange. Neutral axis lies in flange. Okay, so this beam will act samely act as a singly reinforced section. Okay, whatever we have teach in the last unit, third unit, this beam will act as a singly reinforced section. Okay, if I draw its stress diagram, stress curve, then it will be like this. Okay, then your force, tensile force will be at this level. At the level of steel, your TU is there. Okay, and your CU will be. So if you draw the diagram first, complete the diagram first. This portion is horizontal, 0.4 FCK is the stress. Okay, then it is straight, and then it is curved, parabolic. Okay, the diagram is not clear, but you can understand. Okay. So now here you can say this is your CU. This is your CU and this is T. When your depth of neutral axis is less than the depth of the flange, it means that your neutral axis lies in the flange. Okay, and if it is lies in the flange, it is simply its moment capacity is calculated as it is by treating it as a singly reinforced section. Now what are the formulas? So now if I want to calculate the value of this TU, what is the formula for TU? It is same, 0.87 Fy AST. This we have already learned. Okay. Now what is the formula for CU? CU चा तुमचा फॉर्म्युला तुम्हाला माहिती आहे. काय फॉर्म्युला? आधी जुना फॉर्म्युला लिहू आपण. 0.36 FCK B into XU. बरोबर आहे? 0.36 FCK B into XU. But here if you see, here the width is not B. Here the width is not B. Width is BF. Area काय इथं तुमचा? What is the area? This much is the area above the neutral axis. This area you should consider. This much is the area. So how much is this area? This width is BF. This width is BF and this depth is XU. So it is BF into XU. Okay. So here while writing this, instead of B, I will write here BF. BF means width of flange. Okay. Width of flange. Then what is Z? All the rest of the things will remain same. किती distance वरती act होत असणार आहे? It is 0.42 XU. So what is this distance? हे दोघांमधलं काय असणार आहे? Z. Lever arm. So lever arm Z is equal to, it is D minus 0.42 x. It is D minus 0.42 x. Okay. So these are the things. So this is your case number 1. This is your case number 1. Here I will write Z D minus 0.42 x. And the rest of the things you know that if x is less than x max, under enforced, x is greater than x max, over enforced, and then we will analyze. Okay. Now as most of the time I was not here for the lecture, so what we will do, tomorrow we will keep an extra lecture, okay, so that we can finish this last things. So tomorrow at what time? Tomorrow at 3 p.m. Is it okay? Are you hear me? Tomorrow at 3 p.m. we will take the extra lecture. Okay. Tomorrow also I am having some workshop, but still we will take the lecture 3 to 5. Okay. 3 to 5. Okay. So 3 to 5 we will take the lecture and we will finish this. But before that you do one thing. After 1 p.m. म्हणजे 11 ते 1 किंवा 1:30 माझा वर्कशॉप असणार आहे. सो आफ्टर 1 p.m. तुमचे मोबाईल तुमच्या जवळच ठेवा. So if I get more time, then we can start our lecture earlier, so that we will get more time. Okay, so that may be also the possibility. So tomorrow after 1 p.m. keep your mobile with you at least before the starting of the lecture, up to the starting of the lecture. Okay, so today we will stop over here. Drop your roll number into the chat box, and tomorrow be prepared for extra lectures. It's 1. Okay, so we are learning about P beam and L beam, and we have talked about case number 1. What was our case number 1? So our case number 1 was when your XU is less than DF, that is depth of neutral axis is less than depth of flange. This is XU. XU means what? It is depth of neutral axis. Okay, and DF means what? DF means it is depth of flange. Depth of flange. Okay. So when your XU is less than DF, then we have seen the condition and the formula. And when XU is less than DF, what is the formula? The formula is Cu is equal to, that is your compressive force, 0.36 FCK. B into XU is our normal formula for singly reinforced for the beams. So here instead of B we will write BF, width of flange. Okay. And what is the formula for TU? It will remain same, 0.87 FYAS. Okay. Then again the further things are same, under enforced section, over enforced section. Then we will calculate the MU. This was our case number 1. This we have already discussed. Now we will move to case number 2. What is our case number 2 in the case of T and L beams? Okay, so the case number 2 is when your XU is greater than DF. XU is greater than DF means what? The depth of neutral axis is greater than the depth of the flange. Okay, depth of neutral axis is greater than the depth of the flange, and DF is less than or equal to 0.43 XU. So these are the conditions which are given, and so both at a time. Here I have not written or. हे किंवा हे असलं तर or असते, आणि हे दोन्ही पाहिजे फर्स्ट अँड सेकंड, मग आपण अँड नी जॉईन करतो. So XU is greater than DF and DF is less than or equal to 0.43 XU. Means what? Now let us see. I will draw both the cross sections T and L so that it will be easier for you to understand. Same concept will be applied for the L section also. Okay. So now this is the L section. Now T section I will draw. This is the T section. Now see basically what does it says. It says that XU is greater than DF. Now what is DF? You know that this is DF. This is DF, depth of flange. This distance. This is DF. This is also DF, depth of flange. In case of what we can say L beam, I will write cleanly. So this distance, this point, and this distance. This is nothing but this is your DF, depth of flange, and this is what? This is your BW, width of wave. This is also your BW distance, width of wave. Okay, and this we called it as this distance. This is your BF. BF means width of flange. B stands for width, D stands for depth. This is BF in case of L beam. This is BF in case of T beam. Okay. Now XU is greater than DF. What is the meaning of this? The depth of neutral axis is not lies in the flange. This is the meaning of this. DF पेक्षा greater आहे म्हणजे DF इथून ते DF चे जेवढं distance आहे, whatever may be the distance of DF from the top. See, whatever may be this distance of DF from the top, XU is greater than that. So XU maybe is below this DF. Now if I draw the diagram again, so now this here maybe your neutral axis is there. This is nothing but this is your neutral axis. Neutral axis. Okay. And now if I draw the stress distribution diagram, now if I draw the stress distribution diagram, then it will be look like, see, I will draw the diagram. Okay. So here I will show the reinforcement in the T beam. So at this level, your tensile forces will be there. Now if I complete the diagram, now what is 0.3 XU distance, that I will tell you. Where that parabola starts, this is 0.3 distance. Okay, up to this point, and here I will join this. Okay, so if you see from this point, okay, if you see from this point, this parabolic curve starts. Okay, this is straight and then this is parabola. So from top up to this point where this parabolic curve starts, this is 0.43 x. This distance is 0.43 xu, and our compressive force in the case of beams is just above this on 0.42 xu. Okay, so this is the diagram. Now you can see, if I mark this distance 0.43 xu, this is 0.43 xu. Okay, what is the meaning? Now see both the conditions. What is our first condition? First condition says that xu should be greater than df. Okay, so see where is the distance xu. If you see, so this is your xu from top up to the neutral axis. This is your xu. Now you can see your xu is greater than df. Okay, your xu is greater than df. First condition is there. Then df must be less than or equal to 0.43 xu. So this is your 0.43 xu distance, and here it is the df. So both the conditions are satisfied, then this type of diagram will be there. Okay. Now what will happen over here? See very carefully. Now this is the important part which I am going to tell you. So what will happen? See, now this is T section. T action means what? Or L action means what? This is slab. Whatever is the flange is the slab, and beam is nothing but web. But when they casted monolithically and they will behave as the same section, now in this case what will happen? I will draw one more rectangle for your better understanding. This section will act as a same section. हा section जो आहे हा पूर्ण section एक section असल्यासारखा act होतो. Okay, this total section where I have drawn this rectangle right now, red rectangle, this will act as a one section, whole section. Okay, so now this will resist your compressive forces. Now for this section, if I show the compressive force, then this compressive force will be, for this section if I show the compressive force, then this compressive force is like this. Okay, and this now we will call this as CUW, compressive force in web. This section of web. आता काय होते नेमकं तर एवढीच वेब आहे तुमची खालून प्लांटच्या खालून, पण actually when the structure behaves, when the load is acting on the structure, this beam behaves at this part, this extra part which is in the flange. This will behave as it is a part of that beam. Okay, this section, this much of section will behave as it is a part of this web. Okay. So this the compressive force in this web we have shown over here. This is CUW. Okay, and this is as usual. This will act at a distance of 0.42 XU. Okay, so this will act at a distance of 0.42 XU. Okay. So this is the part about this area. Okay. Same is the case in L beam. But now, see, what about this remaining area? हा area राहिलाच ना तरी. So this area, this remaining area of the flange, that is this area of the slab, this will also contribute in the compressive forces. Okay, and due to this flange, due to this slab, additional compressive force will be there in the flange, and this compressive force I will denote. See, this is the additional compressive. Okay, and we call this as CUF, compressive force in the flange. Okay, CUF, and where it will act. The question is where it will act. Okay, so it will act at a distance of df by 2. Now, if I show you the distance, this distance, so this is df by 2. So this distance is it is df by 2. So these two compressive forces are acting. First is due to web, that is this web section. Okay, this whole section will behave as a single section. Okay, web, and second is due to this additional remaining section in the slab, due to which the compressive force is there in the flange. Okay, so this is the stress strain distribution diagram. Sorry, stress distribution diagram. Now, if you see the lever arm, if you see the lever arm, so the distance between these two, tensile force and the compressive force in the web, this is called as ZUW. This is called as ZUW, lever arm. Okay, between the compressive force in web and the tensile force. And then this one, okay, this lever arm, it is called as ZUF. Okay, so this is the lever arm distance between the, we can say, compressive force in flange and the tensile force. Okay, I hope now up to this part it is clear to you. So now we will now write the values of these forces. What are the values? Okay, so first CUW. Okay, first we will go for TU as it is easy. So TU, if I want to calculate the TU, what is the formula for TU? It is same. What stress into area? Force is nothing but stress into area. 0.87 Fy into area of steel is AST. If this area of steel is AST, then it will be 0.87 Fy into AST. TU is over. Okay. Now next CUW. Okay. Now next CUW. So how we will calculate this CUW? We know that for CU, what is the formula? 0.36 FCK B into XU. Okay. So B into XU is nothing but area. 0.36 FCK is the stress. But here you can see 0.36 FCK is the stress. Okay, right. 0.36 FCK is the stress. This we have already studied. 0.36 FCK. But the area is B into XU previously. But now what is the area? You can see this much is the area for this CU force. This much is the area. So how much is this area? So we will always say that the compressive force is always above the neutral axis. So we should consider the area above the neutral axis. So what is the area above the neutral axis? If I say this much is the area above the neutral axis, that we need to consider this total area. Okay, in the case of this UW. So this much is the area above the neutral axis. So what is this area? So this is our width. This width we must consider. This width is nothing but it is BW. Okay, and this depth we should consider. This depth is XU. So our formula becomes, it is area is 0.36 FCK BW into XC. This is in the case of CUW. Okay, this area we should consider. Now next thing is CUF, compressive force in the flange. So in this case of flange, we know that here what is the stress? 0.446 FCK. This is your maximum stress. Again, the compressive force in the flange is nothing but it is stress into area. So what is the stress? Stress is 0.446 FCK. Okay, this is our stress. Now what is the area? So area will be, I will hatch this area again by orange color. See, this area we need to consider for CUF. Whatever I have given here orange or you can say yellow color, it is like this area this area is contributed for CUF. Okay, and this area whatever we have shown here, this it will contribute for CUW. Okay, now CUF high area hai. Okay, so for CUF now we know one dimension. Okay, so you can say that this dimension is DF. This already known to you. This dimension is DF. Now remaining this width we should consider this much of part and then this much of part. Okay, because the central part will be this central part will be the part of this beam. Okay, so we must consider this length plus this length. How much it is? So this total is BF, width of flange. From this point to this point is total width of flange, and this much is BW. So if this much is BW, this is also BW. So what will be the area? It is BF minus BW. Just now you can see that what is the area? This length. How much is this length? This is BF and this is BW. So effective length will be BF minus BW. Okay. So Gaurav, I think you have not attended the lecture when I have taught unit number 3, singly reinforced sections for the beam. 0.446 FCK, because the flange you can see the stresses in the flange is uniform. Okay, the stresses in the flange is always uniform when this DF is less than 0.43 XU, and if the stresses are uniform, the flange is nothing but it starts from the topmost fiber. Okay, and at the topmost fiber, what is your stress? It is 0.446 FCK. But when you talk about this web, if you talk about the CG of this web, so this the compressive force CUW, it is not in the topmost range, it is below the top range. Okay, so that is why the stress intensity decreases. Okay, and that decreased stress intensity is 0.36 FCK. But when you talk about this CUF here the depth of the flange, here the stress intensity is almost uniform. Okay, here the stress intensity is uniform, and at the topmost fiber our stress intensity is 0.446 FCK. So that is why for the compressive force in the flange you consider the maximum stress, and while you are considering the compressive force in the web you don't consider maximum stress. Okay, you consider reduced stress, and that stress is taken as 0.36 FCK. And for the 0.36 FCK, how it comes, that derivation I have taken in unit number 1, that part you can refer once again. Okay, by calculating the area of this rectangle and area of this parabola, we have derived this 0.36 FCK. Okay, but in the case of CUF, you can see this depth of the flange is constant, and for this flange, see, flange means what? It is a slab. And what is the maximum thickness of the slab? Slab may be of 100 mm, or it is up to maximum 150 mm is the thickness of the slab. 100 mm is also more thickness for the slab. 100 mm म्हणजे काय झालं, जर आपण इंचामध्ये बोललो तर it is 4 inch. If you stay, I also consider 150 mm, it is 6 inch. Okay, so 4 inch 6 inch, you can measure it on our scale, which is okay, which is of 15 centimeter. 4 inch म्हणजे किती झालं 10 centimeter. Okay, 10 centimeter only. 150 mm is what, 6 inch. 6 inch means what, it is 15 centimeter only. So that is why the stress is uniform here. Okay, so we have taken it is as 0.446 FCK. Stress is uniform. Okay. After the uniformity for more depth, so suppose now if you take the depth of the slab is now it is 200 mm, it is 230 mm, it is greater depth. So in that case also we take 0.446 FCK, but we consider the area of the slab or the area of the flange up to the stress where the concentration is constant or uniform. Okay, that we will see in case number 3. Now in case number 2, you can see that for the this compressive force in the flange, this is the flange area and the stress intensity is uniform in this flange. That is why we have taken the maximum stress. Okay. So now this is the maximum stress 0.446 FCK. Now area I can say over here BF minus BW is my length, this effective length from this side as well as from this side, and DF is the depth, and DF is the depth. So this is what we can say. This is my CU. Okay. Now see ZUW. So ZUW. So this is the lever arm. So now what is the lever arm distance? See this is 0.46 FCK. Now if I draw over here the effective depth, so this is our effective depth up to this point. This is our effective depth. We denote this by D. So it will be D minus 0.42 XU. D minus 0.42 x. And if you talk about ZUF, now see this distance is DF by 2. Okay, so this will be, it is D minus DF by 2. This is your lever arm for compressive force in flange and the tensile. Okay, so here some important point that I am going to tell you. When your DF is less than 0.43 XU, the stress in the flange is uniform. Okay, and the T beam can be treated as the rectangular beam with width BW and depth DD that we already seen. This rectangular beam can be treated as T beam with width BW. Sir, माझं lecture चालू आहे. So what I am saying that when your DF is less than 0.43 XU, the stresses in the flange is uniform and the T beam can be treated as a rectangular beam with width BW, and so this width is BW, okay, and your depth is X, okay, and the remaining flange width will be BF minus BW and depth is DF, okay. So now this you can also take it down when when DF is less than 0.43 XU, then the stress in the flange in the flange is uniform is uniform, and and T beam can be treated as T beam can be treated as rectangular beam a rectangular beam, that means that a rectangular section of web of width BW and depth D, okay, and and the remaining flange width, the remaining flange width is is BF minus BW and Depth is BF minus BW is the remaining flange width, inverted comma, and depth is again DF. DF is the depth. Okay, so these are the two sections. So based on that, we have calculated. Now see, if we equate Cu and Tu here, okay. So in this case now, if you equate Cu and Tu, then what will be your equation? If you equate Cu compressive force is total compressive force is equal to total tensile force, then this your Cu again divided into Cuw plus Cuf, that is web and flange, and here it is the tensile force. Now if I write the formula for both of them, then it will be 0.36 FCK BW into XU. It is for CUW, okay, compressive force in the web. And if I talk about the compressive force in the flange, then it will be 0.446 FCK maximum stress into your area. It is BF minus BW into DF, okay, and which we must equate this to 0.87 Fy AST. 0.87 Fy AST. Okay, if you understood this, then it is very good. Okay, so it is. I am trying to more simplifying this. Please try to understand. Okay, and if you are having any doubt, you can ask. So now CUW and CUF. This is the compressive force in web, compressive force in flange. We have equate total compressive force to total tensile force to maintain the equilibrium. Okay, our basic concept of equilibrium is resultant force should be zero. Okay, so total compressive force must be equal to total tensile force. Then and then only the equilibrium will get maintained. And that is why if we equate these two forces, then your CUs again get divided into two forces. That is compressive force in web plus compressive force in flange. And those formulas I have written over here. Similarly now, if I want to calculate the moment of resistance MU for this section, now I know if I want to calculate the moment of resistance, then I can say that my moment of resistance is nothing but the moment of resistance of the web plus moment of resistance of the flange, MUW plus MUF. If you further simplify this, then this formula will become moment is nothing but your compressive force UW into its lever arm ZUW. Okay, plus here if you can see, it will be CUF compressive force in the flange multiplied by the lever arm, that is ZUF. So now if I ultimately write the equation for the MU, then this equation will be here first of all 0.36 FCK BW into XU, this is your CU, multiplied by ZUW, it is D minus 0.42 XU. ओके, आधी आपण एवढाच फॉर्म्युला वापरत होतो. इन द केस ऑफ द सिंगली इन्फोर्स सेक्शन, डबली इन्फोर्स सेक्शन एवढाच फॉर्म्युला वापरत होतो आपण सीयू साठी. बट नाउ this CUF is the additional thing. So plus here again in the bracket 0.446 FCK, okay, into BF minus BW into DF. This is our force. This is not the what we can say moment. So multiply this by the lever arm. Now lever arm is ZUF. So what it will be? It is, I will write over it, multiplied by here D minus DF by 2. This is your lever arm. So this is the total equation to calculate the moment of resistance of these T sections and L sections. Okay, see this point carefully. This is the formula we are going to use to calculate the MU. Okay, in the case 2, when your XU is greater than DF and DF is less than 0.43 XU. So these are all the formulas for the case number 2. I hope you have write down the notes and also taken the screenshots. So now we will move to the next case, that is last case, case number 3. Three cases are there. First we have already seen in last lecture. Now we have seen case number 2. Now we will move to the case number 3. So what does case number 3 says? Case number 3 says that your HQ is greater than DF. Okay, and and your DF is greater than 0.43 XQ. The formula is same. Okay, I will give you here the one important note. सी नोट, हे तुमच्या माहितीसाठी आहे बरं का. म्हणजे तुम्ही असं लक्षात ठेवू शकता केस नंबर 2 and 3. ओके. all the formula all the formulas are applicable from case number 2. मी काय म्हणलं, all the formulas are applicable from the case number 2. Okay, only replace df, that is the depth of flange, by yf. Only replace depth of flange by yf. Now what is this yf? So the formula for yf is equal to, its formula is 0.15 xu plus 0.65 df. Okay, by using this formula 0.15 xu plus 0.65 df, you will get the term yf. And if you replace this df in the previous formula case number 2 by yf, then this for case number 3 your formulas will be ready. Okay, now if we see the formulas in case number 2, we are going to apply all the formulas from case number 2. Okay, so what is the formula for, you can see tu, cuw and cuf. Okay, here you can see where is the term, I will underline this, or uh, uh, see here df कुठे येते बघा. So here you will get this term df, here you will get this term df. Okay, so all the formulas are applicable, just you have to replace this df by yf, replace this df by yf. Okay, and formula for yf is also given to you, formula for yf is also given to you. Okay, so now here if I write the formula, then it will be tu is equal to 0.87 FYAST. This will be as it is. Then CUW flange diagram, CUW flange, it is 0.36 FCK BW into XU, it will remain as it is. Then CUF for flange, it will become 0.446 FCK BF minus BW. Okay, into df is there, so here replace your df by yf. So I will multiply this term by yf, and by using this formula, we are going to calculate the yf. Then the next formula, it is lever arm ZUW. So what is the lever arm? It will be same, d minus 0.42 xq. This is the lever arm. Okay, and here what is the lever arm? ZUF. So the lever arm will be d minus df by 2. D minus df by 2 in case number 2. So replace that df by yf. So yf by. So these are the formulas for case number 3. These are the formulas for case number 3. Now if I want to calculate total mu. Okay, if I want to calculate the total mu, then mu is equal to what? Mu of web plus mu of flange. Again mu will be, it is cuw into zuw. Okay, and plus here it is cuf into zuf. So what is mu? So mu will be cuw, cuw is 0.36 fck bw into x. This is your cuw multiplied by z d minus 0.42 x. Okay, this is your first bracket, plus what will be the second bracket? 0.446 fck bf minus bw into df. So instead of df, yf will be there. Okay, and multiplied by d minus df by 2 is your lever arm. So d minus df by 2 is nothing but it is yf by 2. It is yf by 2. It is the formula, it is given in the IS code. Okay, yf is equal to 0.15 xu plus 0.65 ds. This derivation is not for your syllabus. Even any formulas derivation is not in for your syllabus for this T section. It is very vast. Okay, still this is the standard formula. This you will get in the IS code. Okay, for this section 115 XU plus 0.65 DF. So, and what is this YF? So, YF is the distance up to which the stresses in the flange is uniform, and after the YF, the stresses will not become uniform. Okay, and our analysis for the this T section is whenever the stresses are uniform, we can analyze it. Okay, but if you consider the total depth DF, then up to that depth DF, the section is not in stresses is not uniform. So that is why YF is the distance up to which the stresses are uniform. Okay, so you have to remember this formula for the YF. Okay, you can search in SP16 about regarding this. Then 1362 there also you can search this. You will get the more material on this. Okay, so there is small derivation this for this YF is equal to 0.15 XU plus 0.65 df. But you can remember this formula. Okay, remembered it. Very small formula is there. Already I have told you the concept behind all these big formulas. How CW comes, what is ZUW, what is CUF, what is ZUF. If you understand these formulas, then there is no need to by heart it. But you have to remember this formula, which is now for YF. Changes we can made in dia means what? I am not understanding the question. Roll number 65. Okay. What changes we made in dia or what changes made in India? What is that hmm, diagram? What changes? There is no change. Only the change is that your DF. See you. This DF. This DF is greater than this 0.43 XU. This is the only condition. So from here up to this point and before the depth of this DF, it will start parabolic diagram. Okay, it will start to move parabolically. In short, I will show you over here. There is not much more change. See, this is your DF. Now I will enlarge this DF. Okay, and here you can understand now below it is your web. Here somewhere your web will be there, and your neutral axis is in the web. Okay, your neutral axis is in the web. Now if I draw the diagram, see if I draw the diagram. Here somewhere suppose now steel is given, so here your tensile force is there Tu, and if I draw the diagram it will be like this. Okay, this part. Okay. Now df is greater than 0.43 xu. Suppose now your neutral axis is moving from here, this point. This is your neutral axis. So from this point it will be like this. This is your diagram, and this distance it is 0.43 xu. Okay, and this total it is your df. So this is df is greater than 0.43 xu. So in this case, what we will do, we will this whenever this df is greater than 0.43 xu, for the whole depth of df, the stresses will not be uniform. So we will take one certain depth. This we called it, which is near to df, but we called it as a yf. Okay, this depth, and up to this depth. Okay, up to this depth yf, we says that the stresses in this flange, in this area, stresses in this flange it is uniform. Stresses in this flange it is uniform, and very small area remains after the YF to complete the DF. That area we neglect. Okay, remember this. This theory is depending upon whenever the linear stress theory. It is the uniform. You can always establish the relation between stress and strain.
Recording in progress.
Okay. So what I want to say that up to this YF, we says that our stresses are uniform, and from this YF to DF the distance is very less, so we neglect that part because we always do the linear analysis, linear stresses we have considered. Okay, Non-linear analysis is itself is a big topic that you will learn when you will go for the post-graduation course. Okay. So now these are all the formulas which I have told you right now. So based on this, we will take one problem. In this problem, we will cover all the cases, all the three cases. Okay, to calculate the MU. Here to calculate the MU, we will take one problem, and in that we will cover all the cases. So that in a one single problem, all the things will get covered. Okay. So now take down this problem. A T beam, a T beam having having flange width, a T beam having flange width. So T beam having flange width 1400 mm, width of web 230 mm, and and depth of flange depth of flange 40 mm 40 mm. The beam is reinforced. The beam is reinforced with with 4 bars of 20 mm diameter. 20 mm diameter. Use use M20 and Fe 500 steel. Full stop. Find find the moment of resistance. Find the moment of resistance if if effective depth of beam effective depth of beam is 400 mm. Okay, so we will read the problem. A T beam having flange width 1400 mm. So flange width is given to you, that is BF. BF is given to you. Width of web 230 mm. BW is also given to you. Okay, and the depth of flange is 40 mm. So DF is also given to you. BF, DF, BW. All these three dimensions are given to you. The beam is reinforced with 4 bars of 20 mm diameter. So area of steel is also known. 4 bars of 20 mm diameter, you can calculate AST. FCK value is given 20. FY value is given 500. Okay, and the effective depth of the beam is also given. So D, small d is also given 400 mm. So now if I write all the given data, then it will be like this. I will write the given data here. BF BF is equal to 1400 mm. Okay. BW width of web, it is 230 mm. Then DF depth of flange, it is 40 mm. Then what else is given? Effective depth D. So effective depth D is 400 mm. Then FCK. What is FCK? FCK is 20 Newton per mm square or megapascal. Then Fy. What is the value of Fy? 500 megapascal or Newton per mm square. Okay. All these things are given. We will calculate AST here. So area of steel is 4 bars of are given. Each of bar diameter 20 mm. So now let me know the answer. 4 bars each of bar diameter 20 mm. It is 1256.64. Okay, 1256.64 mm square. Please check it. So now this is our area of steel is also known to us. Okay. So now see, we want to calculate the moment of resistance. Problem समजून घ्या. Whether it is T beam, whether it is L beam, things are same. Okay. Note carefully. Whether it is T beam, whether it is L beam, all the formulas will be same. There is no change in any single formula. First, clear with this. Second thing. Now, what they have told us to calculate the moment of resistance. In a examination, it may be T beam, it may be L beam. That doesn't matter. Now for the moment of resistance, first we have to see that these beams comes under case number 1, case number 2 or case number 3. First we have to determine that we are having 3 cases of T and L beam. या 3 केसेस मध्ये नेमकं हे कुठल्या केस मध्ये येतंय ते आधी आपल्याला हुडकावं लागणार and after that we can calculate the moment of resistance. Okay, so right now we don't know anything. So first what we will assume, so first we will assume case number 1 and we will check that it is okay or not. So first we will assume that what is case number 1, we will assume that xu is less than df. Right now we don't know what is the value of xu. We know the value of df. Df is 40 mm, but we don't know the value of xu. So before calculating the value of xu, we assume that our xu is less than df, and let us see what will happen. Okay, so I will say here assume, I will write here assume neutral axis, assume neutral axis passes passes through flange, through flange. So what I have assumed, I have assumed that suppose now this is my area of the flange, sorry, this is the flange. Okay, this is your df, this is bf. So my neutral axis is passing from here, that this I have assumed, this I have assumed. So this is our xu. So naturally what is the condition, you are taking the first condition, xu is less than df. Now again I am saying we are assuming, we don't know what is exactly going on. Okay, we will see it later on. So what we have assumed, our neutral axis passing through the flange. So what, how if I express it mathematically, means what, that is your xu is less than df, your xu is less than df. Okay, this is what we have assumed. Now after this, when I am saying that xu is less than df, now I will take the equilibrium. Okay, so total compressive force must be equal to total tensile force, equating. This is necessary for equilibrium, so we are equating this. Okay, why we are equating? We want to calculate the value of xu. That is why we are equating this. So we are equating total compressive force to total tensile force. Okay, so now what is the total compressive force? Total compressive force in case number 1. Now we can see the formula in case number 1. 0.36 FCK BF into XU. This is for case number 1, which is equal to TU. What is TU? It is 0.87 FY AST. So put all the values. 0.36 FCK is 20, BF is 1400 into XU as it is, which is equal to 0.87 into FY is 500 into AST is 1256.64. So therefore, from this you will get the value of XU. Let me know the value of XU. From the value of XU, we can determine that our assumption is correct or not. 53.23, 54.24. Okay, 54.22, 23. So answer is 54.22 mm, 54.22. Okay. So now see here, XU is 54.22, and what is our DF? What is DF? DF is 40 mm. मग आता XU हा DF पेक्षा लहान आहे का मोठा आहे? आपण काय assumption केले? What we have assumed? We have assumed that XU is less than DF. But you can see that DF is 40 mm. And what is the value of XU? XU is 54.22. So our assumption is wrong. whatever we have assumed it is wrong. So I can write here, okay, our assumption is wrong. Okay, why it is wrong? As xu is greater than df. Okay, किंवा हे लिहिलं तरी चालतंय, तुम्हाला कंडिशन तर माहिती आहे. So you can simply say that our assumption is wrong. Therefore neutral axis lies in web. म्हणजे याचा अर्थ काय असणार आहे, जर न्यूट्रल ऍक्सिस फ्लांज मध्ये लाय होत नाही तर वेअर विल बी द न्यूट्रल ऍक्सिस विल बी इन द वेब. Okay, from this we have conclude to this that first condition is not satisfied, so it may be either from second condition or third condition will get satisfied. So now we will move to next. So before going to the case number 2 here, you can calculate the value of xu max also, but later on also you can calculate the value of xu max. There is no much more critical thing in this. So here you can see our first assumption is wrong. So now case number 2, I will go for case number 2. First case number 1 is fail, that is our assumption is wrong in case number 1. Here I will say that this is our case number 1. Okay, so now when we will move to case number 2, so here I will assume that xu, here you can see assume what we are assume xu is greater than df and df is less than or equal to 0.43 xu. This is the condition. Okay, this is the condition. So here what we have assumed, neutral axis is in back. Okay, so again we will do the same thing to calculate the value of xu by second case. So equate total compressive force to total tensile force. Now this is case number 2. Remember this, your total compressive force must be compressive force in web plus compressive force in flange, which is equal to total tensile force. So it will be, if I write the formula, 0.36 FCK BW into XU for CUW plus CUF 0.446 FCK BF minus BW into DF. Case number 2 is there, so DF. If case number 3 is there, then instead of DF you should write YF. Okay, so DF in case number 2, which is equal to 0.87 FY AST. Now just put the values so that you will get the value of XU. So here 0.36 into FCK is 20 into BW is 230 into XU as it is plus 0.446 into FCK is 20. Here it is in the bracket into BF 1400 minus BW 230 into DF is 40. Okay, into DF is 40. 0.87 into FY 500 AST किती है 1256.64. Okay, now after solving, therefore you will get XU is equal to, solve this and let me know the answer. What is the value of XU? Question is, when we have to check DF is less than 0.43 XU. See, when you are go for case number 2, your case number 2 is XU is greater than DF. In case number 3 also XU is greater than DF. Okay, but in case number 2, what is the second additional condition you need to satisfy? DS is less than 0.43 XU. So unless and until you calculate the value of XU, how you are going to check that DF is less than 0.43 XU or more than 0.43 XU? Okay, when we have to check means after the calculation of the value of XU, then only you can check that your DF is less than 0.43 XU or DF is more than 0.43 XU. Okay, जोपर्यंत तुम्हाला XU ची व्हॅल्यू माहित होत नाही तोपर्यंत तुम्ही 0.43 XU ची व्हॅल्यू काढूच शकत नाही. ही XU ची व्हॅल्यू घेऊ नका केस नंबर 1 ची व्हॅल्यू केस नंबर 2 ला. This value is valid for case number 1 only. The conditions are different for case number 1. The conditions are again different for case number 2. So again for case number 2 you have to calculate the value of xu first. आणि मग तुम्ही एक्सयू ची व्हॅल्यू काढल्यानंतर तुम्ही 0.43 एक्सयू ची व्हॅल्यू काढू शकता. जोपर्यंत तुम्हाला एक्सयूज माहित नाही तोपर्यंत तुम्ही 0.43 एक्सयू काढूच शकत नाही. आणि जोपर्यंत तुम्हाला ही टोटल व्हॅल्यू माहित होत नाही, unless and until you come to know the total value, what is the value of this 0.43 xu, you cannot say that your second condition is this sub condition is satisfied or not. Okay, so when to take this 0.43 xu, my answer is first you have to calculate the value of xu, then only you can decide that your second condition, this is sub condition is satisfying or not. Okay, so first calculate the value of xu now. 78 mm. Okay, others please do check the answer. 78 mm. Okay, so xu is 78 mm. So now we know the value of xu. Now calculate the value of 0.43 xu. What is the value of 0.43 xu? So 0.43 into 78. Let me know the answer. 33.54. करा comparison बघा आता. काय पाहिजे तुमची सेकंड कंडिशन? Your second condition should be df should be less than this 0.43 xu or equal to. So 0.43 xu value किती आली आहे? The value of this, see the value of this 0.43 xu, the value of this 0.43 xu is 33.54. And what is the value of df? The value of df is 40 mm. म्हणजे हे काय झालं? df काय झाला? ग्रेटर झाला ना? df is not less than 0.43 xu. Here df is greater than 0.43 xu. Okay, are you getting my point? So your second assumption is also wrong. Your second assumption is also wrong, because even though your first condition is satisfied, xu is greater than df, your sub condition is not going to satisfy. df is less than 0.43 xu, this is your sub condition. It is not going to be satisfied because xu value is 73, and when you have calculated the value of 0.43 xu, then that value is 33. But according to this condition, your df should be less than this 33.54 or equal to 33.54. But here your value of df is greater. So again, your second condition is also failed. Are you getting my point? So it means that your third condition is going to be satisfied. Okay. So move to case number 3. So this assumption is also wrong. Okay, you can write here, this assumption is also wrong. तुम्ही हे लिहा, आता मी लिहित नाही. Okay, so here you can write that therefore the assumption number 2 is also wrong. Okay, so now case 3, we will move forward. Case 3, normally in the examination, मागच्या एवढ्या वर्षापासून मी बघितलेलं आहे, in the examination it will satisfied in case number 2. कारण की हे प्रॉब्लेम खूप मोठा वाढत जात आहे. इट इज व्हेरी लेंदी प्रॉब्लेम. सो फ्रॉम द पॉइंट ऑफ व्यू ऑफ एक्झामिनेशन, when I see last when there is a written examination, in most of the things, most of the papers, it will get satisfied into case number 2. Okay, now case number 3. What is case number 3? Our case number 3, assume. Now what we will assume? Now we will assume xu is greater than df and df is greater than 0.43 xu. Okay, so again equate. Now first calculate the value of xu. Equate cu equal to tu. Okay, equate cu equal to tu. So once if you equate cu equal to tu, you will get same value of xu. Am I right? You will get same value of xu because cuf means your, I am writing this for your understanding. Cuw here, it is cuw plus cuf, which is equal to tu. Okay, cuw plus cuf, which is equal to tu. This is the formula for cuw. This is the formula for cuf. Okay, so here CUW plus CF equal to TU. But as we are talking about case number 3, what is the major change? We have to replace DF by YF. Okay, we have to replace DF by YF. So if I write over here the formula will be 0.36 FCK BW into XU. This is my first bracket plus what will be the second 0.446 FCK BF minus BW into DF. Instead of DF, I will write over here YF. Instead of DF, I am going to write over here YF. Okay, which is equal to 0.87 FY AS. 0.87 FY AS. But now, what is YF? So, but you know that YF. What is the formula for YF? It is 0.15 XU plus 0.65 DF. This is the formula for YF. Okay, so YF is equal to, it is 0.15 XU will remain as it is. We don't know the value of XU. But 0.65 DF means what? It is 0.65 into what is the value of DF? It is 40. So therefore, ultimately YF is equal to what equation you will get? 0.15 XU plus how much this is? 0.65 into 40, 26. Okay, 26. This is your equation 1. Okay, now put this value of YF, okay, in above equation. Okay, put this value of YF in the above equation. ही जी YF ची value आहे, so put this value of YF over here so that you will get only one unknown in terms of XU. Now if I put this value of YF, this is the value of YF because we are dealing in case number 3, so we have to replace the DF by YF. That is why we have calculated this YF. This is the value, and now we will put this value of YF. Suppose now I will say that this is equation number 1 and this is our equation number 2. Okay. So here I can write, put the value of YF from equation 2 to equation 1. Okay, so now what will be the equation 1 become? It is 0.36 FCK BW into XU as it is plus 0.446 FCK BF minus minus BW into YF. So YF is nothing but here it is 0.15 XU plus 26. All this is equal to 0.87 FY. FY is 500 into AST 1256.6. Okay. Now you can see over here there is only one unknown. You can see there is only one unknown and that is XU. This is unknown XU and here it is XU. So we need to find out the value of XU. Okay. So the answer is 85.45 mm. So now this is the value of XU as per case number 3. Again the same thing. Calculate 0.43 XU. So it is 0.43 into 85.45. What is the answer? XU काढायचा ना आपल्याला value. So it is 36.74. It is 36.74 mm. Okay. So now here you can see this. Your DF is greater than this. Okay. So here XU is greater than DF and DF is greater than 0.43 XU. These conditions are are satisfied. these conditions are satisfied. Now after this, now we came to know that it comes under case number 3. So now therefore mu is equal to, now the moment of resistance mu is equal to, it is muw plus muf. Okay, so mu is equal to, what is muw? It is cuw into zuw. Okay, compressive force into lever arm plus compressive force into flange into lever arm of the flange. Therefore mu is equal to, again 0.36 fck bw xu into d minus 0.42 xu. This is the lever arm. Okay, d minus 0.42 xu. This is the lever arm. Plus इथं काय येणार आहे? So here it will be 0.446 fck bf minus bw into, now this is case number 3, it is not df, it should be yf. Okay, into, what is the lever arm? D minus df by 2, so it should be yf by 2 for case number 3. This is the formula. So therefore we must know what is the value of yf. So yf is equal to, the formula is 0.15 xu plus 26. कुठून आला आहे? From equation 2. Okay, so therefore yf is equal to 0.15 into xu. What is the value of xu? Xu we have calculated it as 85.45, no, 85.45 something, plus 26. So what is the value? 38.82. Okay, so it is 38.82 mm. Just we have to put that value over there. So now therefore I will take the next page. So mu is equal to, here 0.36 fck is 20 bw into xu into d minus 0.42 into xu. Okay, this is your bracket number 1, plus now 0.446 into fck 20 into bf minus bw into yf. What is the value of yf? 38.82 into d minus yf by 2. Okay, so therefore at last you will get the value of mu. Okay, answer is 205.72 kilonewton meter. 205.72 kilonewton meter. Okay. So in this way you can calculate this moment of resistance. Okay, this moment of resistance. This is the thing. So in this numerical now I have covered all the aspects. Okay. See, suppose now here itself in the first case, if your first case here itself gets satisfied. See, it is very lengthy, long problem we have taken. Okay, this much of lengthy problem will not be there in the examination. See, here itself, in the first case itself, if your assumption is get satisfied, then here only you can calculate mu. It is cu into z. Okay, so it will be 0.36 fck bf into xu into lever arm is d minus 0.42 xu. एवढं केलं असतं की तुमचा आन्सर आला असता. Next thing will be, if your first assumption is wrong and if your second assumption gets satisfied. If your second assumption is get satisfied, then this is the formula which I have already told you. Okay, and in this formula you can use only the multiply this by lever arm. Lever armचे फॉर्म्युले पण मी तुम्हाला सांगितले. So df will remain as it is. As it is case number 2, you have to take the value of df as it is. Okay. And if also case number 2 is not getting satisfied, then come to the case number 3. And case number 3, what is the major difference? You have to replace this df by yf. Okay, replace the df by yf. Here also in the formula I have shown. Here instead of df, we have taken yf. So the formula for yf is already written over here. 0.15 x3 plus 0.65 df. Okay. So 0.15 x plus 0.65 df, and we have put the values, and then we have solved further. Okay, after solving this we got the value of xu, then again we check that our conditions are satisfied or not. Here clearly x is greater than df, and here also you can see that your 0.43 xu is less because df value is 4040 and this value is 36.74. So df is greater than 0.43 xu. So these conditions are satisfied. Then for these two formulas, just we have multiplied these three forces by their lever arm distances. Okay. So here mu is the moment of resistance. So mu is nothing but moment in web plus moment in flange. That is your mu. Mu is equal to moment in web plus moment in flange. So here in this way we have calculated this CUW into ZW plus CUF into ZUF. Okay. So now with this now we have covered all the points. Just I will give you introduction about this doubly reinforced section, doubly reinforced T section, so that you will understand the concept. In the examination, the problems will not be asked on the doubly reinforced section, since you can see that singly reinforced sections are very vast. So the doubly reinforced sections, one more force is getting added into the compression, still in the compression zone. So if you understand the singly reinforced T-beam sections, then it is easy to understand the doubly reinforced T-beam sections. Okay, so I will write here doubly reinforced T-beams. Okay, and same is the concept for this also. What we can say, doubly reinforced beam जे आपण बघितले होते, same is the concept is there. Doubly reinforced T-beam or L-beam. Concept is same. So now here, if I draw the beam, this is the T-beam. Okay. Now assume that the reinforcement is provided in the T-beam. Okay. Here normal reinforcement will be their area of steel. This is your AST, area of steel. And in compression zone also now, if the steel is provided. Okay. In the compression zone also now, if the steel is provided, then we called it as AST. We call this as AST. Okay. And suppose now the neutral axis, is passing over like this. This is our neutral axis, suppose. Okay. Neutral axis. Now if I draw the diagram, our stress distribution diagram, then it will be like this. At this level of steel, our tensile force will be there. Here our tensile force TU. TU तुम्हाला already माहिती काय असते, 0.87 FY AST. Okay. All the other forces will be there. Only the additional force is there due to this compression steel. Okay. So if I complete the diagram, diagram will be okay. And now if I draw the forces, see, this is CUW. Okay, this force is CUW. What is the formula? 0.36 FCK BW into XC. You know that. Okay, we know that this total distance is BF. Now I'm not going to write this DF, and this also you know that this total distance. This is nothing but this is your XU, and up to this point, if you calculate the total distance, this you know that this is your effective depth. This is your effective depth D. Okay. So now this is CUW as we have already studied. This is for web. For this section तुम्हाला मैं already सांगितलं आहे हा जो section आहे, this section will behave as a single section. I already told you this much of section. Okay, will behave as a single section. So here CUW, then for flange, this remaining portion of the flange, compressive stress will be there, and it will be here somewhere at the center of this DF. So here I will draw here somewhere it is. Okay, and this is your CUF, which is equal to, what is the formula? 0.446 FCK BF minus BW into DF. Okay, now what is the lever arm of this? Lever arm, you know that this lever arm, this is the lever arm. Sorry, not lever arm, from top, the distance of the force, from top, it is df by 2, not, it is not the lever arm. Then next, this force, you also know that what is the distance of this is 0.42 x, you know that we have discussed lot of times. Now see, हे झालं. आता पुढं पुढ्यासाठी झालं तर नीट लक्ष द्या. हा जो टीयू आहे हा या एएसटी साठी आलाय. या जो सीयूडब्ल्यू आहे, this CUW, it comes for this web section. This CUF हा कुणाला represent करतोय? It comes for this flange section. And now what about this ASC? What is the meaning of this ASC? ASC means that area of steel in compression zone. We have also seen that what is the stress at this level? We know that what is the stress? It is FSC. We have already studied. FSC is the stress in compression, and here we always take the stress as Fy. So now this also there will be the additional compressive force, and that compressive force now I will draw over here. This is the compressive force, third force, and this is uh, what I can say. This is, I will give the notation CUS. Okay, CUS, and where it is acting. Now where it is acting. Now if I show you this is, तो कुठे ऍक्ट होणार आहे? या लेवलला असणार आहे, या लेवलला लक्षात घ्या. ऍट दिस लेवल इट शुड ऍक्ट. डायग्राम तेवढी अप्रोप्रिएट आली नाही, यू अंडरस्टँड. ऍट द सेंटर ऑफ दिस रेन्फोर्समेंट, जर हे सेंटरला ऍक्ट होत असेल तर व्हॉट विल बी दिस डिस्टन्स? दिस डिस्टन्स इज ऑलवेज डी डॅश, कव्हर इन द कंप्रेशन झोन. ओके, so this will act at a distance of d dash from the top, d dash from the top. ओके, आणि हे मी तुम्हाला ऑलरेडी सांगितलेलं आहे, याचा कॉन्सेप्ट पण सांगितलेला आहे मी तुम्हाला. काय कॉन्सेप्ट आहे याचा? तर व्हॉट इज द फोर्स नाव? फोर्स इज नथिंग बट स्ट्रेस इनटू एरिया. सो व्हॉट इज युअर स्ट्रेस? स्ट्रेस इज एफएससी, स्ट्रेस इन स्टील इन कंप्रेशन. व्हॉट इज द एरिया? एरिया ऑफ स्टील इज एएससी. बट थिंग इज दॅट, तुम्ही जेवढे इथं स्टीलचे बार टाकलेले आहेत तेवढं कॉन्क्रीट काय केलेलं आहे? तुम्ही रिमूव्ह केलेलं ना. Okay, so that much concrete you have removed. So our formula will become, what will be the formula? So I can write over here CUS is equal to what? FSC minus, so FSC into ASC total, ह्याच्यातनं मी मायनस काय करणार, कॉन्क्रीटला मायनस करणार 0.446 FCK इंटू ASC. जेवढा एरिया स्टीलचा आहे तेवढाच एरिया कॉन्क्रीटचा आहे. हे सुद्धा आपण ऑलरेडी डिस्कस केलेलं आहे. दिस ऑल्सो वी हॅव डिस्कस while I have taught you the doubly reinforced section. Okay, so the same concept will be here. So this will be finally become, it is FSC minus 0.446 FCK into ASC into ASC. Okay, now the question of lever arm. So this already known to you, this lever arm. Okay, this we call this as a ZUW. Then second lever arm will be this one. This is your second lever arm. This we have already known to us. It is ZUF. And now the third thing is this lever arm from this point. This is the lever arm. Okay. And this we called it as a ZUS. These are the three lever arms. So already I have written over here the values for the forces. I will only write the lever arms. This is for your, just for your introduction. I am telling you all these things, explaining all these things, because if one of the question from the MCQ comes, then you should know what are the types of forces which are acting over here. So only there is one additional force. That additional force is due to this compressive steel. Okay, so now if I write it, then your ZUW is equal to D minus 0.42 XU. This is your what we can say lever arm. ZUF, what is your lever arm for ZUF? It is acting at a distance of DF by 2. So it will be D minus DF by 2. Okay. And now ZUS, where it is acting at a distance D dash, या level line. Okay. Where it is acting at a distance D dash at this level. And this total is D. So lever arm will be the distance between these two. So it will be D minus D dash. So this will be, this we have also studied in past. D minus D dash. Okay. So neatly draw this diagram. Okay. Neatly draw this diagram. So here you can see, if I equate, see, I am having somewhat less time. I have to go for meeting. Okay. So here if you equate total compressive force to total tensile force, then this will become first CUW plus CUF plus CUS, which is equal to total tensile force. Now if I write the formulas, it is 0.36 FCK BW into XU. This is for CUW plus CUF 0.446 FCK BF minus BW into DF. Okay, this is VF plus CUS sky. It is FSC minus 0.446 FCK into ASC. This is your CUS, and all this we can equate to 0.87 FYAST. Okay, this is when you equate C equal to T. And now if I want to calculate the moment of resistance MU, so MU will be MUW plus MUF plus MUS. So just you have to need to multiply each force by its lever arm. So CUW, it is 0.36 FCK BW into XU. No, before this I will write down the formula, so that, see, the things are very easy. Just you need to understand this. First ZUW. Okay, CUW into ZUW plus, here it is CUF into ZUF lever arm plus here CUS into ZUS lever arm. Okay, now if I write down the formula, MU is equal to, here it is 0.36 FCK BW into XU into lever arm is d minus 0.42 xu. This is the first term, plus second thing is 0.446 fck bf minus bw into df into what is the lever arm? Lever arm is d minus df by 2. This is the lever arm. Plus third one. What is third one? Third one is FSC minus 0.446 FCK into ASC multiplied by lever arm. What is the lever arm? It is D minus D dash. So this is the formula for it. So there is no cases in W info section, just this one equation. That is U equal to TU is one equation and MU is equal to MUW plus MUF plus MUF. This is the another equation. Okay. Just you have to use that. Just put the values, you will get the answer. Okay. So in this way, the formulas are there in the W reinforced sections also. I have explained this because maybe in the MCQ the question from this can be asked to you, because for the written examination over these last so many years, they have not asked a single question of W reinforced key sections. Okay. So maybe this time MCQ is there, so I have explained you what exactly it means. Okay, so that some Gaurav has messaged me that to explain about the ultimate load of the column. So now Gaurav, the time is very less. You can tell me your difficulty on the WhatsApp. Whatever problem you are having regarding that, you can message me detail in the WhatsApp. I will give you the answer. Okay. So with this now we have covered all the points, all the syllabus. Okay, everything is covered here. So now from here onwards, okay, whenever our lecture is there or even if our lecture is not there, I will give you the Google links on the group. Okay, MCQ test, you might have given the MCQ test for the other subjects also. So same way I will draft some MCQ test, near about 6 to 7 MCQ tests I will draft for you. So in these 6-7 tests, almost all the MCQs will get covered, okay, from that Google form, and you have to solve that MCQs and download that Google form or the question from that Google form. Those will be your question bank for the MCQs. ओके. आणि मी जे टेस्टला तुम्हाला आता क्वेश्चन टाकणार आहे एमसीक्यू ला, ते सगळे क्वेश्चन पेपर मध्ये आलेले क्वेश्चन्स असणार आहेत. ओके, अपार्ट फ्रॉम द 7 टेस्ट नाउ विच आय एम गोइंग टू कंडक्ट फ्रॉम युअर सी, फ्रॉम हियर ऑनवर्ड्स we are planning for your gate lecture also or something else is there, but even if though other activities are going on, you have to attend the test. It will take only half an hour to solve the test, not much more questions I will add. Whatever the important MCQs are there, those will be there in your test. So you have to solve that. And if you are having any difficulty, you can ask me. I will give you the answer. You can ask me through the WhatsApp. If our lectures will not be there, I will just send you the Google form. Okay. So now start your study. Do your study hard. Read IS code. Read SP16. Read your books, reference books. Refer these lectures. I hope now most of the you have taken the notes. Go through these notes. These notes are very important. Let me tell you. I am not telling you this because of that notes are given by me. My personal experience is that after the students passing B, now previously this subject for final year, you know that now it is for third year. बीई झाल्यावरती मुलं माझ्याकडे येतात की सर तेव्हा तुम्ही शिकवलेले ते नोट्स द्या, तसंच येतंय गेटला किंवा तसंच येतंय एमपीएससी ला वगैरे. So right now, whatever I have given, many of you may understand 70%, 80%, 90%, 95% from this. Even if you have not understood the 100% of this, keep these notes with you as it is. Okay, this will be very helpful for you. Correct. So Gaurav is saying that sir, upload the lectures on YouTube, please. Okay, definitely I will upload the lectures on the YouTube. Okay, till now, while I am uploading the lectures, it will take some time. See, let me frank with you, internet problem is there. Sometimes we are not in the college. Sometimes when I am in the college, it will be easy for me to upload because you see that lot of fast network is required to upload the whole you lecture on the YouTube. The lecture is almost 1 hour, 1.5 hours, 2 hours. So you can imagine that what is the size of that lecture. So I will try to upload it. It may take 3 to 4 days time. Up till now, previously, जे मागचे मुलं होते ना त्यांना मी DCS 1 शिकवले. You can refer this channel, Civil Technocrats Education. Okay, Civil Technocrats Education. In this channel, you will get the link. Okay, Civil Technocrats Education. On this channel, this is also my YouTube channel. My YouTube channel. So here civil technocrats may be there. S is there or not, I don't know. You can search by both the ways. Here you will get these lectures of DCS 1. Okay, for time being, if you come across any difficulty, you can refer through this unless and until I have upload these lectures. Okay, but I will surely upload within 2 3 days. Without fail, I will do that. Okay, so up till now, if you are having any problem, you can refer this. And still, if you are having any problem while studying, please WhatsApp me. आणि तुम्ही मला व्हॉट्सअपवरती न्यूमरिकल पाठवलं मी बघितलं आणि माझा रिप्लाय तुम्हाला आला नाही 1 2 दिवसात तर यू कॅन कॉल मी because the lot of activities are simultaneously going on. I am teaching for you, I am teaching for final year also. Then somebody from second year may ask me the difficulty from the structure. So I forgot many of the times I forgot. So at that time you can call me within 1 or 2 days you have not got the answer for your difficulty. Okay. So all the best for you for your examination. Do the hard study. So we will stop over here. Okay. So all the best.